Wow. All right, so I forgot some things, as Yvette pointed out, and Michelle forgot them as well. But Yvette caught them.
Good job with that.
All right. Here's your brain.
Here's your brain undressed.
Here, I'm taking it apart. Turning it around. You already learned the cingulate gyrus right here. You already learned the cingulate gyrus. I missed the corpus callosum.
You gotta hold up so the light's right.
I missed this corpus callosum right here. It's the largest commissural fiber in the brain. Fibers. Commissural means connects the hemispheres. So commissural fibers connect the right and left hemisphere. The corpus callosum is the largest commissural fiber. This is the posterior commissure right here by the pineal gland. It's so close to the pineal gland in the superior colliculi that you got to be careful of these three. This is superior colliculi, this is pineal, and that's posterior commissure. This is the anterior commissure. By the way, you're saying, how does it connect the two hemispheres? Because they exist over here as well, and this goes together. So they connect the two hemispheres. This little ridge right here running back from the anterior commissure is called the fornix. That's the fornix. It's right below the septum pellucidum. Here's the septum pellucidum. Here's the fornix. Here's the anterior commissure. Here's the posterior commissure. It reminds you for a landmark, here's the interthalamic adhesion. Okay, now, this is a little bit difficult. If I were to take my finger and push it in this lateral fissure, you're going to say, I know, Kiggins, you're going to hit the insula. Yes, you'll hit the insula. But if you take your finger and push it in this lateral fissure and then curl your finger downward, like this, downward, curl it, you're going to touch the hippocampus. So let me take this apart. Let me take the midbrain and brainstem out. I'm putting my finger through the lateral fissure, curl it downward. There's the hippocampus. That's the hippocampus. So let me put this back together without the midbrain and brainstem in there. The hippocampus is right here. I'm touching the hippocampus. Well, I was. The hippocampus is right here. Hippocampus is where you take memories and potentiate them and put them into storage. So you can talk about putting short-term memories into long-term memories there. This is the hippocampus right here. Okay. Now, we have ventricles. And the problem is that ventricles are a hole, a cavity in the brain. So really this model, which is broken a little bit, is a model of a hole. Now it's hard to make a model of a hole because this doesn't really exist. It's a hole. I got another model that will give you an example. This is a slice of the brain. It's a parasagittal slice of the brain. Remember what parasagittal means? It means right and left portions, but not equal right and left halves. This is the lateral ventricle. This cavity right here is the lateral ventricle. I actually think it looks like the Jaguar on the Jaguar cars. If I look at my Jaguar car right now outside, it has that shape on the front of it.
That's non-existent.
Now, I think this looks similar. This model right here is showing you all four ventricles, but it's showing you a lateral ventricle right here. Does this not look similar, the shape right here, to this right here? I think it does. So that's a lateral ventricle. So let's look at this model right here. Here's a lateral ventricle. Here's the other lateral ventricle that's falling off. They go through the interventricular foramen right here, down into the third ventricle. Let me turn this sideways. Down into this third ventricle where the stick is. Now you might say to myself, you might say to yourself, or you might say to myself also in an email, you might say, hey Kiggins, why is there a hole in a hole? Because see, I have a stick going through a hole. So remember, this whole model is a model of a hole. The answer is this. That hole doesn't exist. What runs where that stick is right there is the interthalamic adhesion. In other words, this interthalamic adhesion right here, which you already learned, that runs through the third ventricle. So that's a good landmark to orient yourself. Then, going from the third ventricle down is this cerebral aqueduct, and it goes down into the fourth ventricle right here. The ventricles are lined with choroid plexus, all this pink stuff. Pink, pink, pink. The ventricles are lined with all that choroid plexus. Choroid plexus is capillaries associated with a glial cell called ependymal or impendymal, depending on who you are, which makes cerebrospinal fluid. So the choroid plexus, in essence, makes cerebrospinal fluid. It's actually the impendymal cells that make it from the choroid plexus. The cerebrospinal fluid goes into the ventricles and they circulate. The only part I didn't cover is the circle of Willis, and you can look in your textbook. The arteries are all labeled for you, so go ahead and look at your textbook. You can look at the arteries of the circle of Willis. If you have, what book you have? If you have Seeley, it's on page 719. If you have Martini, it's on page, send it.
I think it was 717.
Send it.
I think it was 717.
Pronto. If you have Martini break, it is on page 739. Over.
59.
As you were. It's on page
7.